All right, hi year 11s, this is Mr. Lim here again, and this is our video about concentration, first one, and it's moles per liter. So let's get started. All right, we're gonna do some math. So, let's have a look. Aqueous solutions can have varying amounts of solute dissolved in varying amounts of solvent. So you can dissolve different amounts of solute in there, right? And so therefore the concentration is a measure of the amount of solute dissolved in a certain amount of solvent. All right, and that makes sense. We've dealt with concentration before in year 8 and stuff. So this is just a way to quantitatively, which is put numbers to it, measure that stuff. So we're going to be looking at moles per liter in this video, and then we're going to be looking at the other units in the other videos. All right, so let's get started with some examples. Okay, so mole per liter, most common unit. Okay, so as you're going to see, so the concentration, remember, is the amount of solute per volume of solution. All right, and then you can rearrange this equation to various ways to get you what you need. All right, so let's go have a look at some of these calculations. So let's do these. So how many moles of sodium chloride are in 5.2 liters of 1.2 mole per liter sodium chloride? So this one here, we want the number of moles of sodium chloride, which will be equal to, N is equal to CV. Okay, and this is on your data sheet as well. Right, so the concentration 1.2 times 5.2 is some value. It is 6.24 mole. Okay, nice and easy. Next, how many moles of nitrate ions are there in 650 mils of 0.5 mole per liter calcium nitrate? So we are looking for, first of all, we can get the number of moles of calcium nitrate, okay, which will be equal to CV again. So that's going to be C is 0.5 times 0.65, because we need this in liters. Okay, so 650 mils is in liters, and that'll be 0.5 times 0.65, 0.325 mole. However, we are asked for the number of moles of nitrate ions, not the number of moles of calcium nitrate. So the idea is that this information and this information is for calcium nitrate, right? However, we want nitrate ions, so therefore we need to do a little bit more work. So we need to say that, okay, what's the number of moles of nitrate ions compared to the number of moles of calcium nitrate? And there is a 2-to-1 ratio. So therefore there's 2 nitrates per calcium nitrate. So I'm going to take that value for calcium nitrate times it by 2, and that'll be 0.65. Okay? Now, please make sure that when you get asked for an ion, right, you've been given information about the salt, you always have to have this line, even if this is just a 1. If there's a 1-to-1 ratio like the calcium, so if this was number of moles of calcium to the number of moles of calcium nitrate, that you would still need that line, and you'll still need it to times it by 1. Okay? This one just needs to times it by 2. So, how many grams of sodium phosphate solid are in 200 mils of 0.02 mole per liter sodium phosphate solution? Okay, so again, number of moles of sodium phosphate, and this is why you need to memorize all of your ions so that you can write out salt formulas reasonably quickly, right, is equal to CV, which is equal to 0.02 times 0.2, which is some value, right? 4 times 10 to the negative 3 mole. Okay, then I need to work out the mass of that sodium phosphate, which will be equal to N times big M, which will be equal to 4 times 10 to the negative 3, which I will save as A on my calculator, because I'm going to have to multiply it by the molar mass of sodium phosphate. So that's 3 times 22.99 plus phosphate, which is 30.97 plus 4 oxygens, 4 times 16, which happens to be 163.94, which will be equal to, times that by A, 0.65656 grams. Okay, so that's that one there. Okay, next. What is the concentration of the solution formed when 2.6 moles of sodium chloride is added to 1.3 liters of water? Nice and easy. So the concentration of sodium chloride is equal to N on V, which would be equal to 2.6 on 1.3, which happens to be 2.6 divided by 1.3 is equal to 2 moles per liter. Okay, 2 moles per liter. Next, what is the concentration of barium ions when 18.2 grams of barium nitrate is dissolved in 400 mils of water? So now I need to work out the number of moles of barium nitrate. Which will be equal to mass over molar mass, which will be equal to 18.2 over whatever the molar mass of barium nitrate is. So it's a 137.3 plus 2 times 14.01 plus 6 times 16, which will be equal to 261.32, which happens to be 18.2 divided by answer, 0.0696 moles. Okay, but I want the concentration of barium ions. So the number of moles of barium ions in the number of moles of barium nitrate will be, times it by 1. There's 1 barium per barium nitrate, so that'll be 0.0696 mole. Okay, and then I can work out the concentration. So concentration of barium ions will be equal to N on V, which will be equal to 0.0696 over the volume of 0.4, which happens to be 0.174 mole per liter. Okay, right. Next one here, what is the concentration of potassium ions in the final solution when 100 mils of distilled water is added to 90 mils of potassium sulfate? Okay, so the idea is that you're adding extra water to change the volume. So you, first of all, remember that you're working out concentration. So you still need moles and you still need volume. So we have to work out how many moles there are of stuff. So I can work out the number of moles of potassium sulfate via CV. So that will be C 0.35 times V 0.09. Okay, let's move that down a bit and let's go work on that. Okay, which is equal to 0.35 times 0.09, which would be equal to 0.0315 mole. Now, because it's asking for potassium ions, we got to go convert that into potassium ions. So the number of moles of K plus ions is equal to the number of moles of K2SO4 times 2, which happens to be 0.063 mole. Okay, then I want to say that I've added 100 mils is added to 90 mils. So my new volume, so I can write volume solution would be equal to 90 mils plus the 100 mils. So that's 190 mils. So the concentration of potassium ions will be equal to N on V, which will be equal to 0.063 over 0.19, which will be equal to 0.332 mole per liter. Okay, that's the concentration of the potassium ions there. All right, can't emphasize how important this step is. And then also that if you're adding two solutions together, you got to work out the total volume to get any final concentrations. Okay, so let's go on to the next one. All right, determine the volume needed to create a solution of a certain concentration. So what volume of needed distilled water needs to be added to 13 grams of magnesium sulfate to form a solution of 0.5 mole per liter sulfate ions? Okay, so first of all, remember we want volume, so we want to rearrange the equation to get V, but V is still related to N and C, so we still need to get N. So the number of moles of magnesium sulfate here is equal to 13 over magnesium sulfate, which is equal to 24.31 plus 32.07. What version have I got here? 32.06, because that's changed recently. And what am I doing? 4 times 16. So 120.37, which is equal to 0.1 0.08 moles. Okay, that's the number of magnesium sulfate that I have. I want to form a solution with 0.5 moles per liter. So the volume of magnesium sulfate is equal to N on C. So therefore that's 0.108 over the concentration that we require, 0.5, which will be equal to 0.216 liters, which is effectively 216 mils. Okay, so that's that one there. Yep, okay, what have I missed here? All right, I missed out the fact that this is sulfate ions. Okay, so since that's sulfate ions, I have to take this, oops. Okay, I'm just going to erase this. No, I'm going to squeeze it in, see how we go. All right, so I can do the number of moles of SO4 minus is equal to the number of moles of MgSO4 times 1, which is equal to 0.108, and this should go before that volume of magnesium sulfate. Okay, so you got to read what you're asking for. You got to make sure that you give the right thing, not the wrong thing, like I just did there. Right, so I should be able to cross that out there and write SO4 2 plus 2 minus. Okay, so that's that one there. All right, so next, let's have a read of the next question, and let's read it properly. What volume of distilled water needs to be added to 1.8 grams of lithium nitrate to make it a 0.002 mole per liter solution? So this doesn't say lithium ions or nitrate ions, but they actually have got the same. They've got the 1-to-1 ratio, so we'll just work out the volume that's needed to make a 0.002 mole per liter lithium nitrate solution. So number of moles of lithium nitrate is equal to 1.8, right, divided by lithium nitrate. So lithium 6.94 plus nitrate 14.01 plus 3 times 16, right, which is 68.95. 1.8 divided by that answer is equal to 0.026 moles. Okay, so then I want to get the volume for the lithium nitrate solution, which will be equal to N on C, which will be equal to 0.026 over the concentration to side, 0.002, which will be 13.05 liters. That's how much water you're going to need to add. Okay, and then what volume of distilled water needs to be added to 7.6 grams of sodium phosphate to make a concentration of sodium ions less than 0.1 mole per liter? All right, so we're dealing with sodium ions here now. So I got to remember to do that sodium conversion between sodium phosphate and sodium ions. So let's move this down a bit, give me a bit more space. Okay, so what you got? First of all, we need to work out the number of moles of sodium phosphate. So you've really got to memorize your ions, otherwise this is just going to take forever. Okay, so 3 times 22.99 plus phosphate 30.97 plus 4 times 16 will be equal to, so that's 7.6 over 163.94, which happens to be some value. Okay, so you should remember how to use the shortcut buttons on your calculator to do things like 7.6 divided by answer after I had added all of those things up, just to save you a bit of time. Okay, what's next? Now we're going to work out the number of moles of sodium ions from the number of moles of sodium phosphate, which will be equal to that times 3, because there are 3 sodiums per sodium phosphate. So times that by 3 will get you 0.139 moles. Right, that's how much that I've got there. So I want the volume then of Na plus to be equal to N on C. All right, and that will get me to 0.1 mole per liter, so 0.139 over 0.1, which happens to be 1.39 effectively. All right, liters. Okay, so read that question carefully. You need to have to make a concentration of sodium ions less than 1.1 mole per liter. So therefore, at least 1.39 liters or you should probably say more than, more than 1.39 liters, because 1.39 liters will get you to 0.1. So you want it to be less than, you add more water, and then the concentration will be lower. All right, so let's move on. Okay, last one. These ones are a little bit longer, so let's have a look at these ones here. So a little bit more complicated. So 100 mils of 0.2 mole per liter calcium nitrate is mixed with 150 mils of 0.5 mole per liter sodium nitrate. What is the final concentration of nitrate ions? So I'm going to color code this. I'm going to work out, first of all, the number of moles of calcium nitrate, right? Because that's the first thing, which will be equal to CV, which will be equal to 0.2 times 0.1, which happens to be 0.02 mole. And then the number of moles of nitrate ions from the calcium nitrate will be double the number of moles of calcium nitrate, considering there's a 2-to-1 ratio, 0.004 moles. Okay, then I'm going to do the sodium nitrate. So the number of moles of sodium nitrate will be equal to, again, CV, which will be equal to 0.5 times 0.15, which will be equal to something. Let's go save that number first. So 0.2 times 0.1 times 2. Save that as A. Then I'm going to do the next one. 0.5 times 0.15 is equal to 0.075 moles. And the number of moles of sodium or nitrate ions here will be equal to the number of moles of sodium nitrate times 1, because it's the same value. There's one thing per thing, one nitrate per sodium nitrate. And I'll save this as B. Okay. I should also consider, let's just move across a bit. I should also consider the fact that the volume total will be equal to 0.1 plus 0.15, and this is all in liters, 0.15, so 0.25 liters. And so therefore I can say that the number of moles of NO3 total will be equal to A plus B, which will be equal to 0.115 moles. And therefore the concentration of NO3 minus total will be equal to N on V, 0.115 over 0.25, which will be equal to 0.46 mole per liter. Okay, so that's that one there. Couple of different steps, but you had the idea that you can add moles of stuff together. Let's have a look at the next question. So, what volume of distilled water needs to be added to 40 mils of solution of 3.2 moles per liter magnesium ethanoate to have 0.3 mole per liter of ethanoate ions? Okay, so this is very similar, but instead of it being a mass, it's a volume. Okay, so let's go through this one here. First of all, we need to work out the number of moles of magnesium ethanoate, because that's what we have. That's 2 there, that's a bracket there. Okay, so magnesium ethanoate is equal to CV, which would be equal to 3.2 times 0.04, which is some value. 3.2 times 0.04. 0.128 moles. Okay, then I have to work out the number of moles of ethanoate ions from that. There's 2 of them, so I times that by 2. Right, that gives me 0.256 mole per liter. Oh, just moles, sorry. Okay, so what volume of water do I need to have here? So the volume that I need is equal to, N on C, which will be equal to, 0.256, 0.256 over the concentration required, 0.3, which happens to be something, 0.8533 liters. Okay, so this is the tricky bit. You can convert that to mils if you want. That's not the tricky bit. The tricky bit here is that what volume of water needs to be added to 40 mils to make it up to this concentration. The idea of that is you want the final volume to be this. So the volume added will be equal to 853, because that's what we wanted to end at. Subtract that 40 that you started with, and that's 813 mils. That would get you 2.3, because if you because you got to read the question, it's how much do you need to add, right? And there's an initial volume, so you take away that to get to the final volume that you want it to get to. All right, last question. 20 mils of 1.2 mole per liter sodium phosphate added to some amount of calcium nitrate to form calcium phosphate precipitate. Once the reaction has occurred, either the calcium or phosphate ions will be in excess. Okay, work out which one is in excess and work out the concentration. So this is a limiting reagent question, right? So we need to do a limiting reagent question. We need to work out the equation first. So we might do phosphate ions plus calcium ions turns to calcium phosphate. Okay, solid, this is AQ, this is AQ. Right, and we'll need to balance that equation. So that's a 3, that's a 2 there. So now I have a balanced equation for this, so I can start doing the limiting reagent. So first of all, I work out the number of moles of sodium phosphate that I have. Number of moles of sodium phosphate is equal to CV, so that's 1.2 times 0.02, which is equal to some value, 1.2 times 0.02, which is equal to 0.024 moles. The number of moles of phosphate ions is equal to the number of moles of sodium phosphate times 1, so it's the same value. There's 1 phosphate per thing, per sodium phosphate, so that's fine. Right, this is the amount that I have. Now I can do the next one, which will be the number of moles of wasamajigi calcium now. So now I'm working out the number of moles of calcium nitrate. Calcium nitrate, which will be equal to CV, which will be equal to 0.77, times the volume, which is 0.03. So 0.77. Oh, wait, I'm going to save that value that I've got as A. Then do 0.77 times 0.03, which will be equal to 0.0231 moles. The number of moles of calcium, 2 plus ions, will be equal to the number of moles of calcium nitrate times 1, which will be equal to 0.0231 moles again. That'll be B. Okay, so this is the amount that I have. Remember to do limiting reagent. What have I got to do? I've got to go work out the amount that I need of one of them. So let's just select the phosphate needed, which will be equal to the number of moles of calcium ions that I have, times 2 on 3, so that's the coefficient of your unknown over the known, right? And it's unknown how much you need so far. So this will be B times 2 on 3, which happens to be some value, which is equal to 0.0154 moles. That's how much I need, right? So then I can do the next part here. Let's move this down a bit. Oh, not much space to move down, but we'll see how. All right, so now I can say that the number of moles of phosphate that I have compared to the number of moles of phosphate that I need Which one is larger? It's the one that I have. So therefore, I have more than I need of phosphate, so therefore my calcium ions are my limiting reagent. If those are the calcium ions that have a limiting reagent, the phosphorus is in excess, so the PO4 3- is excess. So now I can say that, okay, the number of moles of phosphate ions, excess, will be equal to the number of moles of phosphate ions have, subtract the number of moles of phosphate ions need, and I was lucky to pick the right one that I needed, so I've got A, subtract, and I've still got this value here, and I'm going to save it as C, subtract C, A subtract C is equal to 8.6 times 10 to the negative 3 moles. Okay, so that's the number of moles of that ion in excess, and that's concentration there. So now I have to say that, okay, the concentration of those PO4 3- ions excess will be equal to N on V. N will be 8.6 times 10 to the negative 3, and the volume will be the total volume, so 0.05. So I don't have to show that in a calculation, but you've got to get it right, and divide that by that, and that'll be 0.172 mole per liter excess. Okay, and that's it. Hopefully that's helped. I'll see you in the next video. Adios.